Okay, I've already done congruent figures, and I said that congruent figures means they are exactly the same. They have the same shape and they have the same size. Okay, and the symbol for congruent is these three lines. Am I right? That's one. Okay, and I said that when you label the diagram, it has got to be ordered. All the letters have to be ordered. Am I right to say that? Yes. Okay, and I told you to do some work in your textbook itself for congruent figures. Exercise 7A. Am I right? Pick up the 7A. Alright, question 1. Which pairs of shapes are congruent? I think this one, any problems with that? Can identify? Yes. Then I also told you that figures undergoing translation, rotation or reflection, it doesn't change anything. They will still be the same shape and size. Right? Okay, next. Question number 2. Is there any problem filling in the blanks? Can you fill in the blanks properly? Can I? I think that is quite a guided kind of question. There shouldn't be any problem. Question 3. Write down all the missing measurements. Are you okay? Yes, huh? Okay. Question 4. Are the following pairs of triangles congruent? If so, explain your answer and write down the statement of congruence. If not, explain your answer. I told you already, for triangles to be the same, all three angles must be the same, all three sides must be the same, and it must be the corresponding side. Okay? Alright, any problem with question 4? Everybody okay? Yes, good. Then I've done 5, 6, and 7, right? Yes or no? 5, 6, and 7 with you, and you have already added in. Okay, now today we are going on to similar figures. Okay, page 175. Now, look at page 175. Figure 7.5a shows 3 cups which look alike but are of different sizes. Figure 7.5b shows the projection of a photograph on the screen using a visualizer. Now, I told you already, similar figures, the original one, let's say, is like that. If it's bigger, it's an enlargement. If it's smaller, it's a reduction. Is that clear? It's a reduction. Now, where will it be an enlargement? For example, if you look at the microscope for a certain small thing, you enlarge it. Or you use a binoculars. Understand? You enlarge it. Or magnifying glass. Okay? Where will it be reduced? When you take a picture of yourself, it's reduced. But it must be reduced in proportion. If not, it will be out of proportion. Do you understand? Okay? Alright, now next. Can we look at page 175? Okay? In the middle there. Two figures are similar if they have exactly the same shape, but not necessarily the same size. Now, what do we mean by that? Now, I will use a triangle as an example. Now, if let's say this is 420 degrees, this is 30 degrees, this is 20, and this is 40. Now, can you see that all the angles are the same? Okay, now, let's have a look. Let's say this is 8 cm, then 3 cm, 5 cm. 6 cm, 16 cm, 10 cm. Now what do you realize here? Yeah. Can you see that all the angles are the same? And then all the length is in the constant ratio. It means I multiply by 2. If you go this way, I multiply by 2. If you go this way, I what? Multiply by 2. Now if this is the original figure, this will be a large figure. But if this is the original figure, this one will be a reduction. Okay? All the lengths must be in proportion. Now, I will take this up. The lengths are in proportion, but not the angles. Because angles cannot be in proportion. Otherwise, this is 180, then this one no longer is 180. You understand? If it becomes 90, then it's wrong already. And someone it will not have the angle the same way, then it cannot be similar anymore. A lot of people have a misconception. They always think that if length is proportion, angle is also proportion. That's easy rubbish. The angle got to be the same. When you take a picture, your eyes looks a bit strange. No, right? It must be the same eye, right? So the angle must be right stretch as well. Everybody clear? Okay? Alright, so this is called similar. Huh? Now, then I want to ask, if I have another one, is this similar to this? It's congruent, right? Are congruent figures similar? The answer is yes. Because it's multiplied by 1. Can you see? Congruent figures are similar. But similar figures need not be congruent. Unless the ratio is 1. Do you understand what I'm talking about? Okay. Yes or no? Now, for this to go to this, can you see everybody I times 2? How about for this to go to this? I times 1, I still get the same figure, right? That means it's not an enlargement, not a reduction, it remains the same. It's still similar. Just that now it's congruent as well. It's similar and congruent. Do you get what I'm talking about? So I repeat, congruent figures are similar, but similar figures need not be congruent. For example, these two are similar, but are they congruent? No, because they need not have the same size. Okay? Alright, okay, now, then we look at page 176 at the bottom. Okay? No, before that, page 175 first. After that box down there, if two similar figures also have exactly the same size, then they are congruent. In other words, congruence is a special case of similarity. Just bear that in mind, okay? Now, next page, at the bottom, page 176. If two polygons are similar, then all the corresponding angles are equal and all the ratios of the corresponding sides are equal. Now, the condition here is the word and. This is important. Later I will differentiate to you. Triangle is less stringent. Polygon is more stringent. Now, polygon means it can be 3 sides or more. Right now, the simplest polygon, last year we have done. The simplest polygon we have is a triangle, right? What do you call a 4-sided figure? Polylateral, very good. 5-sided. 5-sided. Pentagon, right? So on, okay? All these are called polygons, okay? Now, let's take a look, okay, at the bottom here. If two polygons are similar, then all the corresponding angles are equal and all the ratios of the corresponding sides are equal. Let me give you an example. Look up here. If I have a square, all this should be 99. Now, if let's say this is 4 square, now I have another square. Can you see that these two will be similar? Because all the angles are the same and all the sides are of ratio 2. Can you see? Times 2. The scale is 2. Can you see it? Okay. It must be both same angles and the sides must be proportional. Okay, let me give you another one. I told you the important condition is what? And now what if it's a ball? Now what will this figure give you? If I have 4 sides equal, it's a rhombus, right? Do you agree it's a rhombus? Because all these are parallel. Okay? Now, let's say this is also a sphere. Now, do you agree that all the sides, because a rhombus and a square has got all sides equal. So if this is a rhombus, sides will be 8 cm. Do you agree that this one and this one is of ratio to the length? But are the angles the same? No. Are they similar? They are not similar, right? A square will never be similar to a rhombus, am I right? Because a rhombus do not have all 4 angles equal. Everybody okay? So the condition here is what? Is n. I must have angle and side proportional. Understand? Okay, I'll give you another one. Now, first one is a square. What about the second one? Rectangle. What is the same? All the angles are the same, right? But are all the sides in proportion? No. Can you see that this is of ratio 2? What about here? 1. Cannot. Do you understand what I'm talking about? For it to be similar, all angles must be the same and all sides must be proportional. The important thing is n, not all. If it's all, cannot. Understand? Okay, now let's take a look at page 176 again. Okay? If two polygons are similar, then all the corresponding angles are equal and all the ratios of the corresponding sides are equal. Can you highlight the word n? Either underline or highlight the word n. Okay. Then I want you to turn to page 178. Is what? Hexagon and so on, right? Now, all these must follow the rule that I said just now. Now, for triangle, we are less stringent. It's all. Understand? It's not n. Okay, now why? Let us look at the question, the summary here, page 178 at the top there. If two triangles have equal corresponding angles, or the ratios of the corresponding sides are equal, then they are similar. Now, if I have two triangles, let's say 80, 40, 60, right? Correct. And I have another triangle, 80, 40, 60. You don't need to go and construct and whatever. The two triangles will naturally similar. As long as the three angles are the same, the three sides will correspond to be proportional. Okay? Only when it goes to 4 sides onwards, then it must be an n condition. If it's a triangle, it's an all condition. Everybody clear? Okay. Likewise, if let's say I have a triangle, I don't have the angles. Let's say all these angles are missing. I have 2 cm, 3 cm, 4 cm. What do you realize here? All the sides are in proportion, right? I times 3 times 3 times 3, right? Once the sides are in proportion, all the angles will be the same. You don't have to bother. That is a special property of a triangle. Okay? Next year we'll learn how to prove this. This year no, we just assume it. Then we'll give you that the triangles are already similar. Next year we have to prove that they are similar before we can use it. You clear? Okay, so let's take a look at page 178. If two triangles have equal corresponding angles or the ratios of the corresponding sides are equal, then they are similar. Okay? Look at item 2. If two polygons with 4 or more sides have equal corresponding angles or the ratios of the corresponding sides are equal, they may not be similar. Remember? Just now I showed you the square and the rhombus, and then the square and the rectangle. Okay, now look at the next part. For polygons with 4 or more sides, the following conditions must hold true before we can conclude that they are similar. All the corresponding angles are equal, and what's the word down there? N. Okay, and all the ratios of the corresponding sides are equal. Can you highlight that? 2 points there. Either you highlight, put a star there, or underline, or whatever you have. Okay, these 2 are important. Everybody okay? Everybody okay? Alright, good. Now, next, we are going on to examples, okay, before we are going to solve questions, alright? Now, let's take a look at work example 5. All of you look at work example 5. Now the question asks you, okay, let's take a look. Is triangle ABC similar to triangle PQR? Explain your answer. Okay, you shall not explain what you want. 70, 49, what will be this angle? Alright, 80 minus both, right? So what's the angle there? 60? This is 119. So 61. 61, right? Okay. Now, how about this one? Of course, this will be what? 49, correct? Now, you tally. Are the three angles the same? Yes. Now, for similar, there's no short form. Okay, so triangle ABC is similar to triangle. Now, if it's ABC, it must also go in order. So which one? PQR. Why? Because all the three corresponding angles are the same. Alright? Are equal. Okay? Now, then we look at the next one. Okay, look at the next one. Like this. Is triangle DEF similar to STU? Now, I told you the letters must correspond, right? Correct now, class? Okay, now let's take a look. All of you look up. That's how you prove it. Now, if I have DE, it must be over what? ST. What's DE over ST? 8 over 12, right? Which is what? 2 over 3, right? Correct. But we can take this side over that side, also okay, doesn't matter. But if you take this side over that side, everything must be this side over that side. Okay? Now, what about EF over what? If I have EF, must be over what? TU. Okay, good. What's EF? 6. What's TU? 9. It's still 2 over 3, right? You are safe. You see, last leg, what is it? T1. Very good. DF over SU. What's DF? 4. What is SU? 7. Now, is this 2 over 3? No. As long as one of the sides, they don't have the same ratio, they cannot be similar. Is that clear? So, triangle DF is not similar to this because of the different ratio here. Everybody clear? Everybody clear? Can? Okay. So, that's how we do it. Now, next, look at work problem 6. Work example 6. I'm going to go through all the examples first, okay, before we solve the questions. Everybody look as well. So look at the textbook because I'm using a different way again. Okay. Okay, all of you look at the bottom. Given that triangle ABC is similar to triangle PQR. So we have this. Triangle ABC is similar to triangle PQR. We already give you the statement. In exam, don't worry, we'll give you the statement. Clear? Okay, let's take a look here. Calculate the values of the unknowns in the triangles. Okay, I want everybody to look here. Now, x already have degrees, right? Everybody okay? That means x must only be a number. Okay, now, x is which angle? Here. So it must be what? A, right? So what is x? Just take. X is 25, right? Straight away. Everybody okay? Can? Okay, now, next up. Okay. They are similar, they are not congruent. So when I take y, at least I go this direction, I must have y over what? Y is actually BC. So it's over what? QR. Okay, what's QR? 3.2. Correct. Must be equal to now. Choose something to know. So it's what? 7.5 over. Now 7.5 is AB. So it must be what? PQ. Now what's PQ? 5. So can you see it just do a cross multiply? You can get the answer straight away. So I have 5y equals to 7.5 times 2.2, right? So y will be what? Over 5, right? Everybody okay? Just a cross multiply. Or if you do not want, it's also okay to do it this way. Do you agree that y stays here is 7.5 over 5 times 3.2? Because divided by 2.2 bring over become times 3.2. It's the same thing. Everybody clear? Because it's just like that, but I bring this over. Alright, this one is when I cross multiply that I bring over, it's the same thing. Now, can you see that this guy is actually the same as this guy here? Everybody okay? So up to you to solve the equation. Everybody okay? But you must take the corresponding length properly. Okay, now, if let's say the upper is over this side, when you take from here to here, everything must be from here to here. Understand? You cannot say one side you want to take from here to here, the other side you take from here. No, okay, cannot use the wrong ratio. Okay? Alright, so that's your example 6. Alright? Are we okay so far? Are we okay so far? Okay. Next, can we look at example 7? Page 181. Okay, this is the picture given to you. Okay, now let's go look at the question. Nora stands at a point D, 2.0 meters in front of a spotlight at point A. She is 1.6 meters tall and is facing the wall of a building which is 10.5 meters away from her. How tall is her shadow on the wall of the building? That means how tall is, that means I want to find out x, right? Everybody okay? Now, first of all, I need to see whether the triangles are similar first. Now, there's no need to prove it, but we can take a look. Okay? Remember I said for triangles to be similar, we need to have 3 equal angles or 3 sides that are proportional. Okay, now, plus, do you agree that it's not necessary to have 3 equal angles? As long as 2 angles are equal, the third one will automatically be the same. Do you agree what I'm saying? Do I have to have 3? Only right, just 2 will do right. The third one is actually 180 minus than 2, so it will be the same. Okay. Now, I want to look at this small triangle. Do you agree that if I draw the 2 triangles out, is A, B, D, and A, B, C. Correct. Can you see that there are 2 triangles super equals to one another? Okay, this is the world. Then if you cannot see, please draw it out separately. Okay, now, do you agree that if this angle is here, this Agree or not? Because it's a common angle, they share the same angle. Agree? Now, what else? Standing up, we will expect the fellow to stand perpendicularly. So this is 90, this will also be 90, right? The wall will be 90. 90, 90. Now plus, if these two angles are the same, it will follow that the third angle will be the same, right? Correct? Okay, because three angles add up must be 180. Okay, now we fill in the unknowns. This is 2.0 meter, this is 1.6. Now, how much is AB? Yes, 12.5. Do you understand? You do not enter right now. This is what? X meters, right? Now, what are we looking for? Whole class. What are we looking for? X. Okay. X over what? 1.6. Good. Will be 12.5 over 2.0. Agree? Yes. X will be 12.5 over 2.0 times what? Times what? 1.6. Okay. We'll get the answer. How tall is the shadow? Or how high is the shadow? Is that clear? You will get your X as 10 meters. Understand what I'm talking about? If you key in the calculator, this is 10. So the shadow is actually 10 meters. Are you all okay with example 7? Yes or no, class? Okay. Now, what have I covered today? I have just covered similar triangles and similar figures. Okay. Because of the scolding, I cannot finish example 2. I will leave example 8 to tomorrow. And make sure tomorrow when I come in, okay, there are no nonsense. If not, I'll leave again. Then you are the one suffering. I don't care. Really not, I don't care. Alright, you know, stop the video. No homework for today. Make sure you go and revise.